Not saying any names. All right, quiz number 2. Mark your own. Number 1 says, how many odd 3-digit numbers are there? Number 1 is not worded clearly because it doesn't say whether I'm allowed to repeat or not. So I'll take both answers. I'll do one answer and one answer without repetition. It's the fundamental counting principle. 1, 2, 3. If it's an odd number, the last digit has to be odd. I'm allowed 5 choices. If I'm allowed to repeat, that means I put the number back in. There's 10 numbers in the bag. How many choices do I have for the first one? Well, only 9, because I can't start with a 0. Put the number back in, give it a shake. There's now 10 numbers in the bag. This one, the answer is going to be 450. I would accept that. Or, if you did it without repetitions, you'd still have 5 numbers, but now you'd only have 9 numbers left in the bag, but only 8 are in play because you can't start with a 0. Now you have 8 numbers left in the bag, and they are all in play, and you get 320. I'd take that as well. The question wasn't clear. On the test, it will be clear whether you're allowed to repeat or not. Number 2, how many ways are there to arrange? The word arrange is code for permutation. You could do this several ways. You could draw 1, 2, 3, 4, 5 blanks, or you could say it's 5 factorial, or you could say it's 5p5, but no matter what, the answer is 120. How many ways are there to arrange? Oh, and that's because there's no repeating letters in my last name. How many ways are there to arrange 4 letters? Well, that you could draw 1, 2, 3, 4 blanks and go 5, then 4, then 3, then 2. Or you could go from 5, permutate 4 at a time. But you also get 120, don't you? How many ways are there to arrange the letters of the name of van der Velden? Do some letters repeat now? Okay. Then we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 factorial divided by 2 V's, 1 A, 2 N's, 2 D's, 3 E's, 1 R. I already did V's, 1 L. It's going to be that. Now on my calculator, I'm not going to type all that in. On my calculator, I'm going to go 12 factorial divided by, and I'm going to evaluate the small factorials in my head. That's 2 times 2 times 2 times 6. In fact, you could have gone 2 cubed times 6 if you're really lazy. Anyways, you get 9,979,200. Just about 10 million ways to mix up Mr. van der Velden's last name. Not quite. Number 5, there is going to be one of these on your test, some kind of an algebraic solve, either permutation or a factorial or a choose question where there is an n to solve for. Well, first thing you really needed to do is go find your formula sheet and find the permutation equation, which is that the permutation equation says NPR is the first thing factorial over the first thing minus second thing factorial. The first thing factorial over the first thing minus the second thing factorial. That apparently worked out to 210. Alex, I can tidy up the bottom. What is n minus 1 minus 2 really? Yeah, I can rewrite this as n minus 1 factorial all over n minus 3 factorial equals 210. Can I just cancel out the exclamation points? No. What I have to do is expand one of these until I find the bottom or the top term in the term that I'm expanding. Which one do I expand? Vlad, I simply ask, which is bigger? Which is bigger, n minus 1 or n minus 3? So I'm going to expand that. N minus 1, 1 less than that is n minus 2, 1 less than that is n minus 3. I could keep going, but that seems to be what I want to cancel out in the denominator. fact, I get n minus 1 times n minus 2 equals 210. In fact, I get this. N squared minus 3n plus 2 equals 210. What kind of an equation is this? It's a quadratic. How do I know? Why, it's got a squared. How am I going to solve this? Oh, how am I going to solve? Oh, make it equal to 0. Now, when I did that, I got n squared minus 3n minus 208 equals 0. I don't really know my 208 times table, so I started guessing. The first thing I thought was maybe 208, maybe 12 work? Nah. And I said, well, how about 208, maybe 16? I'm trying nice number. Oh, 16 and 13. How far apart, Maria, are 16 and 13? What do I have right there? I can make this work, I said to myself. I said, this is going to factor into n minus 16, n plus 13 equals 0. My roots are 16 and negative 13, but Spencer. Sorry, Trevor. And if you got that, you get 2 out of 2. In terms of part marks, I gave a half mark if I saw that. I would probably give a half mark if I saw that you got to this line right here. I would probably give a half mark for getting to there. I would give a half mark for the answer, but if you didn't cross out the extraneous, I'd take a half mark off. And then I would turn the page. On your test, I'm going to give you some kind of a simplify, get rid of factorials expression. I think, Trevor, it's reasonable to assume that I can, in my mind, break it up that way with the numbers and the letters with the letters, variables with the variables. I said 102 factorial over 100 factorial. Well, that I can do. That's going to leave me with 102 and the 101, but then the 100, the 99, the 98 would cancel out with the 100, the 99, the 98 in the bottom. Then I look at this. I drew a fraction bar, and I said, okay, I got an n minus 4 on the top and an n minus 2 on the bottom. Kara, which one's bigger? So I'll start to expand n minus 2. That's n minus 2, n minus 3, n minus 4. Ooh, I'll stop there. And I said this whole thing works out to 102 times 101. Whoop, 102 times 101. 10,302 on the top. And the bottom, you could leave it as n minus 2, n minus 3. You could FOIL it out to n squared minus 5n plus 6 if you wanted to as well. I would give you 1 mark for the top, 1 mark for the bottom. And there's your 2 marks. I like number 7. I like number 7. I like number 7. Number 7 is a nice question. There's going to be some kind of this on your, some kind of committee question on the written section. So class consists of 4 girls, 7 boys. 3 students are chosen at random. How many ways can you select? Now, A, when it says a president, a secretary, and a treasurer, I think that means, Eric, the order that you're picked matters, because there's different titles for each position. It's a permutation. How could I do that? Well, there's a couple of ways. I could say, well, I'm drawing 3 blanks. They're not distinguishing, Justin, between males and females, so it's 11, then 10, then 9, which is actually 11 permutate 3, which is 99 times 10. 990, is that right? Any 3 people, well, now the order doesn't matter. That's a choose. From 11, choose 3, and that's going to be, I have no idea, 165. Now we're going to go into subgroups, boys and girls, or cards, spades and not spades. Subgroups, bucket. Girls and boys. How many girls? 4. How many boys? 7. How many do I want to choose? 2 and 1. It's going to be 4 choose 2 and 7 choose 1. I think 4 choose 2 is 6. I know 7 choose 1 is 7. Is it 42? D. Key phrase here, at least. I have to list the cases. At least 1 girl, that means 1 girl or 2 girls, or 3 girls. What does or mean? One girl would be from 4 girls. I'll use this bucket up here. Choose 1. From 7 boys, choose 2. There's my 3 kids. Or, I already did 2. I'll just copy it right down. Or, from 4 girls, choose 3. 7 girls, choose none. Four, choose 1, 7, choose 2. 84 plus, this one I already know the answer to is 42, plus, what's anything choose 0, Mitsu? And 4 choose 3, that's the same as 4 choose 1. Hey, that's 4. In fact, this whole thing just works out to a 4. You'll get 84 plus 42 is 126 plus 130? Is it? In terms of part marks, I would give you 1 mark for that line, 1 mark for the answer. And then I would turn the page. Order matters in a permutation, doesn't matter in a combination. Number 9, new Toronto license plates. 4 characters are letters, 3 characters are numbers. This is a job for the fundamental counting principle. It says repetitions are allowed, so I think it's going to be I got 26, I got 26, I got 26, I got 26, I got 10, I got 10, I got 10, because a license plate can begin with a 0. The short way to type that, Alex, would be 26 to the 4th times 10 to the 3rd, and you get 4, 5, 6, 9, 7, 6,000. 4, 5, 6, 9, 7. 456,976,000 possible license plates. What if we can't repeat? Well, it's going to be fairly similar, but now it's going to be still 1, 2, 3, 4 blanks and 1, 2, 3 blanks, but it's going to be 26, 25, 24, 23, 10, 9, 8. Or you could have gone from 26 permutate 4 and from 10 permutate, not choose, Mr. Dueck. From 10 permutate 3, 26 P4 and 10 P3. You get 258 33 6,000. $258,336,000. That's how many don't repeat. That's how many there are. Hey, how can I figure out how many repeat? Subtract those 2 numbers for what it's worth. And then there's going to be a couple of pathway problems on your test. One, a regular one like this, which means although you could use Pascal's, I can use a shortcut. I can go right 3 times and down 5 times and say, hey, that's an 8-letter word with 3 rights and 5 downs, and then I might even notice there's an even shorter way that turns out to be the same as 8 choose 3. $56. Can you give yourself a score, please, out of count 'em 18? Make sure your name is on it, and then pass it inwards. If you were away, put a big... Let's try that again. Right-click. Open your books, please, to page 413. Page 413. The binomial expansion theorem. And while you're on this page, I'm going to turn back 1 page, just so you can see a quick reminder of what we did. We said, all right, if you're expanding a binomial, there is a shortcut pattern, Joel, and the pattern says, look at the exponent, we'll call that n. Your coefficients are partly going to be n choose 0, n choose 1, n choose 2, all the way up to n choose n. That might not all be your coefficients, because there could be numbers inside the binomial that will make their way into the coefficient later on as well. We called the first term A, and we said it's going to be a to the n, a to the 1 less, no a's. We called the second term B, and we said there's going to be no b's in the first term, then 1, then 2, then 3. That was the pattern. That pattern you will have to memorize for the test. That pattern is not on your formula sheet. What is on your formula sheet? Well, we said, Vlad, if I just want you to find one term, you can use this puppy here, which looked confusing but wasn't too bad. I would normally start out by taking questions from the homework. However, I'm going to finish off the lesson, and I think that will answer some of the questions. So, example 3. I like example 3. I like example 3. I like example 3. Example 3 says expand that. I'm going to say, hey, try this one on your own. I'll do it up here. Use the binomial expansion theorem. By the way, what's my exponent, Dominique? How many terms will there be? 4. Built-in error, check. Try expanding it using the pattern, carefully substituting, and I'll do the same thing up here. Let's see if we end up with the same place. See if you get what I got without just copying down what I got. Not that I'm mentioning any names. This one was kind of nice because I actually knew most of the chooses in my head. Am I right? Yeah? Yes? Mitzi, thumbs up. Brett, thumbs up. So you have this on your test on the written, except Brett, instead of a 3 as an exponent, I'll probably put like a 12 there. But I'm not going to ask you to expand the whole thing, because if there was a 12 there, how many terms would there be, Alex? I'll just ask you for the first 4. I figure if you can get the first 4, you can do the remaining if you needed to, but first 4. So I like that question, sort of. Alan, make it a bigger exponent, just ask for the first 4 terms. How many got that okay? Good. I like example 4, I like example 4, I like example 4. And example 4 is a nice question, it's going to be on your test. Example 4 says this. When we expanded this thing, although we don't know what's sitting there, somewhere along the way we got that. The only thing I don't like about this question, Kara, is what letter is sitting right there? In my traditional setup, what letter have I normally had sitting right there? You know what? Let's be clever. All of us right now, instead of an A, make that a B and find B. Just so it looks like we want it to look. Now here's what this is saying. somewhere along the way, when you FOILed this out, you got that. What has to go there so that when you FOIL this out, you get that? Now, the key to doing this is we need to figure out what term this is. Is it the first term, the second term, the third term, the last term? And there is a way to do that. And it's to look at this x. To look at this x. Trevor, what's my exponent? So the first term would have an x to the 10th in it, because that's sitting where the a is, yes? What would the second term have? An x to the 9th, right? All of you put your pencils down. All of you hands up in a fist, two fists. What did you say the first term would have? An x to the 10th, thumb out. Then an x to the 9th. Then an x to the 7th, 6th, 5. When will an x to the 4th, like the question that they gave me, appear? Emily, what term number is this one that they gave me? Term number what? Aha! I want you to write down. It's term 7. And the only way I know to find that, by the way, is to actually count on my fingers. Okay. The next thing, now that I know that it's term 7, Carly, I'm also going to use this bad boy here. Which hopefully you had written at the top of the page, or you might have to turn back one page to get that. Term k plus 1 equals m choose k, a to the n minus k, b to the k. What's n? In this question, what's n? 10, yes? Let's make the little note over here. How about right here? N equals 10. What term do I want, Spencer? So I want a 7 to appear there. What would I put in for k so that a 7 would appear there? What's a in this question? X. What's b in this question? It's a trick question. B is equal to b. Let's fill in as much as I can on the right-hand side then. N, 10. Choose k, 6. X to the 4th. B to the 6th. And then don't write this next bit down. Don't write this next bit down. I was going to say that's term 7, but wait. I can be even more specific because I know what term 7 is. What is term 7? So instead of writing term 7 over here, I'm going to write 3, 2, 8, 1, 2, 5, 0, x to the 4th. You with me so far, Tyler? And something kind of cool happens because this is all being multiplied and this is all being multiplied. I can cancel out the x to the 4th. So I can say you could divide the x to the 4th out. And I end up with this. 3, 2, 8, 1, 2, 5, 0 equals. What is 10 choose 6? Can somebody actually evaluate that for me? Sorry? 210 b to the 6th power. Now what? Solve for b. How? Get the b to the 6th by itself. How? Divide by 210. And I think I end up with b to the 6th equaling what? 15,625? Okay. Now that's b to the 6th. How could I figure out what b is? How to get rid of a 6th power? Sixth, if it's a squared, square root. If it's a cube, cube root. If it's a sixth root. Now I would write it this way. B equals the sixth root of 15,625. Where the heck is sixth root on my calculator? Well, what root did you say, Ellen? I'll type a 6. Math. Here is your nth root button, option number 5. Once you press math. The sixth root of 15,625. I think it's 5. Ah! There it is. Okay. There's going to be a question like that on your test, where I give you part of the term, but I give you what the term worked out to be, part of the original binomial, but I give you what the answer was, and I'll say, go backwards, what does the question have to be? First, you'll have to use the x's, Ryan, the exponents on the x's, to figure out what term number it is. Then you use the tk plus 1 equation to backtrack and solve. I also like number 5, example 5. I like example 5. I like number 5, example 5. Sabina, what does number 5 want me to find? The constant term. Say what? What's another word for the constant term, Sabina? I.e., what else do we call it? The term independent of x. Say what? Here's what it's saying. Look at your binomial. Do you notice the first term has x's on the top? Ah, but the second term has x's where? Do you think it's possible that somewhere along the way they cancel out? Eric, do you think it's possible that because I have some x's on the top and some on the bottom, that somewhere along the way they would cancel out and there'd be no more x's left? Say yes. Do you know what we call that term? Or the... What this is saying is, hey, look, you got some x's on the top, you got some x's on the bottom. If you were to expand this, somewhere along the way, your x's would vanish. Find it. Okay, so that's the question. How do we do that? What I really want to do is I want to start out just looking at what's going on with the x's. I know there's a 2 there. I don't care about the 2 right now. I will later. I know there's a -1 there. I don't care about that right now. I will later. Brett, what's my exponent that we're starting out with? I think what that means is in my first term, I'd have an x to the 15th. Yes? In my second term, I'd have an x to the 14th. And I'd have a 1 over x squared to the 1. There's my a to the 15th, a to the 14th b. In my third term, Alex, would I not have an x to the 13th and a 1 over x squared to the 2? Yes? That's enough. I'm going to stop there. If I can't figure it out from 3, I'm not that clever. We're going to look for a pattern. Here's the pattern we're going to look for. How many x's grand total in this question? 15 of them. How many x's grand total here? Well, 14 on top, 2 on the bottom. How many left and where? How many x's grand total in the third term? Well, 13 on the top. How many on the bottom? Don't say 2. How many on the bottom? How many left and where? Emily, can you sense a pattern in the exponents? What's the pattern that you see? This is why I said you can always spot it after 3. What's the pattern that you see? Pencils down, fists up. So if I hear you correctly, Emily, the first term has an x to the 15th, yes? Second term has x to the 12th. Then 6, then 3, then when will there be no x's? Term number what? 6. Aha! They want me to find term 6. That's the only way that I know of to write out this pattern. And you could probably figure it out from 2, but you might have made a mistake. I figure if you write out 3 and all 3 of them hold the same pattern, you haven't made a mistake accidentally. Oh, by the way, what's n? 15. What's k? Careful. 5. What's sitting where the a is? 2x. Now I'll bring in the 2 because I'm actually now doing the question. I didn't care about the 2 here, Ryan, because it wasn't going to change the x's pattern, right? But now I do. Oh, and what's sitting where the b is? Careful. It's not 1 over x squared. Negative. Okay. So it's going to be n 15. Choose k 5. A 2x to the n minus k to the 10th. B negative 1 over x squared to the k to the 5th. What is 15 choose 5? I have no idea. 3003? And then I have a 2 to the 10th. What's 2 to the 10th? And then I have an x to the 10th. And then I have a negative 1 to the 5th. What's a negative 1 to the 5th? Just plain old. And then I have a 1 over x squared to the 5th. I think that's a 1 over x to the 10th. And, Kara, have we done this right? What do you notice happens to the x's? Are there any x's left, Kara? Is this the constant term, i.e. the term independent of x? Hey, we've done this right. It's going to be that times negative 1. What is 3003 times, well, it's going to be negative, I can tell you that. 3003 times 1024. Emily, what'd you get? Brianna, could you hear? Because I sure couldn't. Sorry, what? Just read the digits. Three 075 072, and then you muttered something else. Oh, okay, but the digits are right then. 3,000,000 negative 3,075,072. That's the constant term. Okay. Those are the weird curveballs, and maybe hopefully I hope that also helped you with questions you might have had from the homework from last day. What is your homework? What can you add to what I already assigned? You can add nombre dos, that's number 10. And you can add number 11. And I have for you a great big take-home quiz. Take a look at the quiz that I just gave you, please. Looks like this. So, number 1, fundamental counting principle. Hey, number 2, this is just like the Mr. Vandervelden question, Toronto, Ontario. Number 3, basically asking you, do you know what the formula looks like or how to do it? Number 4, how many different 3-letter arrangements? Arrangements, is that a permutation or a combination? Arrangements is a permutation. 5 is good. 6 is good. Draw a little picture if you need to. 7 is good. 8, so there's our binomial expansion theorem. What's the 7th term of that there thing there? Turn the page. On the written section, number 1, so a standard number fundamental counting principle question. Number 2, I told you I was going to give you on your test some kind of algebraic solve question, so here's an example of that. Number 3, so here's a pathway problem. This one here is irregular. This one here, you'll have to use Pascal's triangle as your method of approach. Number 4, what's the 17th term of the 23rd row of Pascal's triangle? Number 5, here's a committee question. 10 girls, 8 boys. We're choosing a committee of 5 with at least 3 girls on the committee. Number 6, find and simplify the term containing the x to the 14th in that there thing there. That's very similar to what we just did 2 questions ago, where we had to figure out what term is it, when does it appear? Number 7, what is the coefficient of the constant term? Hey, that's what we just did. Turn the page over. Emily, turn the page over if you haven't already. Number 8, write out the first 4 terms of that expansion there. Number 9, Itzel is a disc jockey. She has chosen 10 songs to play for the school dance. Itzel creates one 10-song compact disc. How many different ways can she arrange the songs? B, Itzel realizes that the first 3 songs of the CD are important in setting the tone for the evening. She chooses these 3 songs from the original 10. Math is wonderful, the never-ending algebra problem, and you plus me equals us. Oh, what a great playlist that is there. Wow! How many ways can those 3 songs be placed at the start of the CD? And then C, how many ways can she burn the compact discs if these 3 songs must be at the start of the CD? That's a pretty good indication of almost everything you'll see on your test. When is your test? Wednesday. When is this quiz due? Friday. When is the tutorial? Friday after school. You have the remainder of class